Connected bodies. In the first case, three blocks of masses m1, m2 and m3 are connected by an inextensible string. Force is acting in this direction. Here we have to calculate the acceleration and the tension in the string. For the acceleration, we consider the Newton's law, which is F is equal to ma. Force is equal to mass into acceleration. Here the masses are m1, m2 and m3. Therefore, the total mass is nothing but m1 plus m2 plus m3 into a. Therefore, acceleration a is equal to F by m1 plus m2 plus m3. This is the equation for the acceleration. Here in this case, we have to consider all the masses. Now this is about this acceleration. Now coming to the tension. Here, what about the direction of the tension? If the force is in this direction, what about the direction of the tension? Tension is always away from the point of contact. Say here is the point of contact between the string and the mass. So that this is in this direction, and for this it is in this direction. And here are the 2 points of contacts. The direction of the tension is always away from the point of contact. Now because of m1 mass, here I consider the tension as T1 and here I consider the tension as T2. Now what about the tension T1? What about the tension T1? To calculate the tension T1, now here you just imagine one line which is perpendicular to the surface. Now one force is outside this line and the two forces are on the force direction in this side. Now the tension can be calculated simply by taking the number of forces which are on this side. That is nothing but T1 is equal to m1a, and a is nothing but F by m1 plus m2 plus m3. Therefore, the resultant tension is nothing but m1 F by m1 plus m2 plus m3. And similarly, what about the tension T2? Now for this again, you just imagine a line here which is perpendicular. Now on this side you have the two masses and one force is on this side. Therefore tension is equal to, left side there are the two masses, therefore it is nothing but m1 plus m2 and acceleration is a. Therefore it is equal to m1 plus m2 and the force, substitute the force value F by m1 plus m2 plus m3. Now this is the tension T2. This is about the tensions and the acceleration when the bodies are connected by a string in a horizontal direction. Case 2. A towed machine. In this, two bodies m1 and m2 are connected by a string and they are over the pulley. And this pulley is rigidly fixed to a support. And this pulley is a frictionless pulley. Pulley is a frictionless pulley, and the string is an inextensible string which is passes over the frictionless pulley. And here I consider that masses m1 and m2, out of these two masses m1 is greater than m2. m1 is greater than m2. If the mass m1 is greater than m2, the acceleration of m1 is in the downward direction. Acceleration of m1 is in the downward direction, as well as the acceleration of the m2 is in the upward direction. Because m1 is greater than m2, acceleration of m1 is in the downward direction, it moves in this direction, and the m2 moves in the upward direction, therefore the acceleration is in the upward direction. And what about the tensions here? Tension is again away from the point of contact. This is the point of contact. Therefore, the tension is in this direction T, and for this mass, it is the point of contact, and the tension is nothing but T. It is also in the upward direction. Now, if I consider the mass M1, here the weight is in this direction M1g. Weight of the body is nothing but M1g, and the weight of the body is M2 for the second mass. For the first mass it is M1g, and for the second mass it is M2g. Here again you have to calculate the acceleration as well as the tension. Acceleration as well as the tension. Now, how can we calculate this acceleration? To calculate acceleration and tension, here I consider, see, this body is moves in the downward direction. When it is moves in the downward direction, we can say the tension is smaller than this weight. Tension is smaller. The body is moving in the downward direction. Means weight is greater than this tension. So that you can write the equation as that M1g minus T. M1g minus T, because it is moving in the downward direction. M1g is greater than this tension, which is equal to M1a, and that is nothing but the force, and this is nothing but the resultant force acting on the body. M1g minus T is equal to M1a. Similarly, come to this body. Now for this body, due to M1 is greater than M2, this body moves in the upward direction. This body, while this body is moving in the downward direction, it will move in the upward direction. When it moves in the upward direction, you can say that tension is greater than the weight M2g, and this is again equal to M2a. This is say equation 2, and this is equation 1. By solving these two equations, we can calculate the acceleration as well as the tension. To calculate this acceleration, add equation 1 and 2. Add equation 1 and 2. We get here, if we add these two equations, that is M1g minus T is equal to M1a minus M2g plus T is equal to M2a. If I add these two equations, these two gets cancelled, and the remaining equation is M1 minus M2 into g is equal to M1 plus M2 into a. Therefore, acceleration a is equal to M1 minus M2 by M1 plus M2 into g. This is the acceleration. Now substitute acceleration either in the equation 1 or in equation 2 to get this tension. Now for that, I consider the second equation. Equation 3 in equation 2. Now T minus M2g is equal to M2. Here I substitute the acceleration value. M2 into M1 minus M2 by M1 plus M2 into g. Now expand this. M2 M1 minus M2 square into g by M1 plus M2. This is T minus M2g. Then T is equal to, now move this on to this side, that is M2g plus M2 M1 minus M2 square into g whole by M1 plus M2. Now you can write m1 plus m2 T is equal to m2 into m1 plus m2 into G plus m2 m1 minus m2 square into G. Now take G as the common and expand. This is equal to G into m1 m2 plus m2 square plus m1 m2 minus m2 square by m1 plus m2. Now these two gets cancelled. This gives the tension T is equal to 2 m1 m2 by m1 plus m2 into G. Now this is about the tension. This is the calculation of tension and acceleration, tension and acceleration in a two-D machine. Case 3. Two bodies of masses m1 and m2 are connected by a light inextensible string which passes over the horizontal pulley. Here m2 is on the smooth surface, m2 is on the smooth surface, m1 is hanging. Here also we have to calculate the acceleration as well as the tension. And if m1 is greater than m2, if m1 is greater than m2, this body moves in the direction, in the downward direction, and this body moves horizontally. Now in this case again we have to calculate the acceleration as well as the tension. Now when this body moves in the downward direction, acceleration is in the downward direction, and this body moves in this direction, therefore the acceleration is in this direction. Now what about the direction of the tension? This is the point of contact, therefore the tension is in this direction, in this part of the string, and here this is the point of contact and the tension is in this direction, this in this part of the string. Again the weight here is equal to m1g, weight is in the downward direction, and here the weight is in this direction m2g, weight is in this direction, and because of horizontal surface this weight is balanced by the reaction force. Therefore while considering the tensions, here we write the tension in the string, in this part of the string, tension in this part of the string is equal to T is equal to m2a. This is the tension, T is equal to m2a. And coming to the another part of the string, now for this part of the string, this is in the direction, weight is in this direction, tension is in this direction. Therefore the resultant or the net force is equal to m1g minus T is equal to m1a. Substitute this tension in this equation, that is m1g minus m2a is equal to m1a. To calculate the acceleration, rearrange the terms. This is m1 plus m2 into a, and the a is equal to m1 by m1 plus m2 into g. This is the acceleration in this case, and the tension is this one. Case 4. The body is on the inclined plane and the inclined plane is at an angle theta. The two bodies are now connected by an inextensible string. The masses are m1 and m2. The mass of the string is negligible. Now in this case I consider that the mass m1 is greater than m2. If m1 is greater than m2, you can say this is the weight of the body, that is m1g. And this weight, if the weight is in the downward direction, tension is in the upward direction, because this is the point of contact. And as a result, this body is moves in the downward direction, because m1 is greater than m2. This body is moves in the downward direction, therefore the acceleration is in the downward direction. And for this body, this is the point of contact and this is the direction of the tension. And this body moves in this direction, therefore the acceleration of the body is A in the upward direction. Now, to simplify the condition, here this is nothing but the weight m2g. To find the acceleration and the tension, we have to resolve this into two components. We have to resolve this into two components. If the angle here is theta, the angle here is equal to theta. And this component of weight is equal to m2g cos theta. m2g cos theta. And in this direction it is equal to m2g sin theta. m2g sin theta. Now this component is opposite to the reaction force N. Now we are going to write the equations to calculate the acceleration and the tension. Firstly, consider this mass. Here this mass is moves in this direction, in the downward direction, tension is in the upward direction. Therefore, you can write that m1g minus T resultant force is equal to m1a. m1a. This is our equation 1. Now come to this case. Now the body is moves in this direction, the upward direction, and the weight is moves in this direction. Weight is moves because this mass is moves in the upward direction, it means it will move in the downward direction. If this mass is moves in the downward direction, it will move in the upward direction. This mass moves in the downward direction, it will move in the upward direction. Therefore, in this case, while writing this part, the tension is more than this component. Therefore, you can write that T minus m2g sin theta is equal to m2a. Clear? See, the weight m1 is greater than m2. Therefore, the body is moves in this direction. Weight is in this direction. It will move in this direction. And the tension is away from the point of contact. For this body, the equation is m1g minus T is equal to m1a. Now, for the second body, the body is, if the body is moves in this direction, in the downward direction, m2 mass is moves in the upward direction. Therefore, T is greater than this part, this component of the weight. Therefore, T minus m2g sin theta is equal to m2a. The body is moves in the upward direction. Now, we simplify these two equations. Add equation 1 and 2. Add equation 1 and 2. If we add these two equations, this T gets cancelled. The remaining part is m1g minus m2g sin theta is equal to m1 plus m2 into a. Therefore, the acceleration is equal to m1g minus m2g sin theta by m1 plus m2. Or you can also write this as m1 minus m2 sin theta into g by m1 plus m2. This is the acceleration. Now substitute this value either in this equation 2 or in equation 1 to find the tension. Now that is, I am substituting this value in equation 1. Say this is equation 3. Put equation 3 in equation 1. m1g minus t is equal to m1 minus m2 sin theta g by m1 plus m2. Now you can write this as m1g, move this part onto this side, m1g minus m1 into m1 minus m2 sin theta into g by m1 plus m2. This is equal to t. Simplify this equation, that is m1, I am taking m1 as common and g is also common, and the remaining equation is m1 plus m2 minus m1 plus m2 sin theta by m1 plus m2 is equal to t. These two gets cancelled. Therefore, the remaining equation is t is equal to m2 plus m2 sin theta by m1 plus m2 into g. Here is m1. Or you can write this as m1 m2, taking m2 as common, m1 m2 into 1 plus sin theta by m1 plus m2 into g. This is about the tension, and this gives the acceleration. This gives the acceleration. Case 5. Double inclined plane. Two bodies of masses m1 and m2 are connected by in light inextensible string which passes over the pulley. The inclined planes are smooth and they are at an angle alpha at one end and the beta at the other side. Now here also you have to calculate the resultant acceleration as well as the tension. For this we have to resolve the weight on this side as well as on this side. Now the resolution is shown clearly. This is if the angle is equal to alpha, and if this is the body of mass m1, the weight is in this direction. This is equal to mg, and this weight is resolved into two components. If the angle is alpha, this angle is again equal to alpha, so that this component is equal to m1g cos theta, and this component is equal to m1g sin theta. And here I consider again, as usual, m1 is greater than m2, so that what will happen, this body moves in this downward direction, so the acceleration of the body is in this direction. Now similarly you can also resolve for the second body. Say this is the angle beta and here is the body m2. Mass of the body is m2 and this is the weight m2g, and this is resolved into two components. And if the angle here is beta, this component is equal to m2g cos theta, and this component is equal to m2g sin theta. Because m1 is greater than m2, this m2 is now moves in the upward direction. Therefore, the acceleration of the body on this side is like this and on this side. So, here the acceleration of this body is in this direction and the acceleration of this body is in this direction. What about the tensions? Now this is the point of contact. Therefore, for this part of the string, tension is in this direction, and for this part, this is in this direction. This is the point of contact. Now, to simplify, I am writing the equations. For this mass, it is moving in the downward direction because m1 is greater than m2. Therefore, you can write this component of the weight is equal to m1g sin theta. This component is equal to m1g sin, because it is alpha, this is sin alpha and this is sin alpha. That is nothing but m1g sin alpha minus t is equal to m1a, equal to m1a. Now come to this part. Now when it is moving in this direction, this body is moves in the upward direction. Therefore, the tension is greater than this part of the weight. And here is beta, therefore here it is again equal to beta. Therefore, you can write T minus resultant force, T minus m2g sin beta is equal to m2a. We have to now simplify these two equations. For simplification again, we add these two equations. Add equation 1 and 2. Add equation 1 and 2. This is, if we add, these two gets cancelled and the remaining equation is m1g sin alpha minus m2g sin beta is equal to m1 plus m2 into a. Therefore, the resultant acceleration is equal to m1 sin alpha minus m2 sin beta g by m1 plus m2. Now substitute this value either in equation 1 or in equation 2 to get the tension. Now put equation 3 in equation 2. That is, T is equal to m2a plus m2g sin beta. Substitute this value here. Therefore, this is m1 sin alpha minus m2 sin beta into g by m1 plus m2 plus m2g sin beta. This is equal to m2g is common on both sides. Therefore, m2g, this is m1 sin alpha minus m2 sin beta plus m1 sin beta plus m2 sin beta by m1 plus m2. m2 sin beta gets cancelled. Therefore, this is m2g into m1 sin alpha plus m1 sin beta by m1 plus m2. Now taking m1 as common, m1 m2 g sin alpha plus sin beta by m1 plus m2. This is the tension. This is the resultant tension in this case. resultant tension and this is the resultant acceleration.